August 26, 2014 was a historic moment when New Horizons crossed Neptune's orbit. This spacecraft was heading straight towards Pluto, but this moment was special for us because exactly 25 years earlier, in August 1989, Voyager 2 had also performed a flyby of Neptune. We were repeating history once again. Before this, we had not explored any planet beyond Neptune before this. But in 2015, we made that history as well with the New Horizons mission. During this mission, we explored Pluto, which is known as the King of the Kuiper Belt, as well as several other Kuiper Belt objects. But now, we would like to take another look at the Voyagers. Voyager 1 and Voyager 2 kept making history. They studied all 4 gas giants of our solar system, Jupiter, Saturn, Uranus, and Neptune, in detail. But at the time of launch, their core mission was only to explore the Jupiter and Saturn systems, for which they were also equipped with scientific instruments. These instruments were performing far better than the scientists' expectations. That's why, after both spacecraft completed their core missions, Voyager 2 was assigned to explore Uranus and Neptune in its extended mission. Now, after flying by Neptune, Pluto's orbit was in such a position that it was simply not possible for Voyager 2 to reach Pluto. But Voyager 1, after flying by Saturn, it could have gone to Pluto. But did it go? No. So what was it that stopped us from doing a mission 25 years ago that we could have done? And what would have happened if Voyager 1 had flown by Pluto 25 years ago? We'll find out in today's video. On November 12, 1980, Voyager 1 was actually flying by Saturn at its closest approach. Before this, NASA and the Voyager team had kept Pluto as an option, but by the end of 1980, this option was eliminated. The Voyager team and NASA found the Pluto option a bit too risky. Instead, they had a more exciting and low-risk opportunity available in the form of Saturn's largest moon, Titan. Where NASA found rivers of methane and an atmosphere, clouds would form, and it would even rain there. The chances of finding life on this methane-filled world were also much higher. That's why NASA turned away from Pluto, and Pluto remained unexplored for a long time. But what if? If Voyager 1 had been sent directly to Pluto instead of Titan, Voyager 1 would have reached Pluto by 1986. And by this time, Voyager 2 was still moving ahead after studying Uranus. New Horizons reached Pluto in 2015. But if Voyager 1 had done a direct flyby of Pluto, we might have achieved this feat 30 years earlier. But this journey wouldn't have been that easy. A lot of technical and psychological challenges would be waiting for us. A dark, unknown journey. The biggest challenge before us was that at that time we knew very little about Pluto. And how is it connected to our solar system? What contribution does it make to the solar system? And what can our science gain by exploring it? There were so many such questions, all marked with a big question mark. Besides, that was the year 1986. But we discovered Pluto's atmosphere about 2 years later in 1988. Until then, we had only seen Pluto as a point in the sky. We had no idea what it looked like or what it was like. About 8 years later, in 1994, the Hubble Space Telescope saw Pluto for the first time, and we saw Pluto's surface for the first time. The important thing to note here is that in 1986, we didn't even know the context of Pluto. Where did it actually originate from, and how did this body become connected to our solar system? We couldn't even call it a Kuiper Belt object because Kuiper Belt objects were not discovered until 1992. Even about 6 years after 1986, we didn't even know that something like a dwarf planet existed. And even beyond Neptune, there are many things left to explore. At that time in 1986, we only knew about one thing similar to Pluto, and that was Neptune's moon, Triton. But Voyager 2 was still going to take another 3 years to reach it. We didn't know what to expect from Triton, but we couldn't wait for 3 years. However, we did know about the size of Pluto and the size of its moon, Charon. We also knew that their surface could be made of ice, nitrogen, and carbon monoxide. And as for the atmosphere, well, it hadn't even been discovered at that time. We had no information about the entire system, like how many moons it had, and this information is very important for any flyby mission so that we can do all the calculations while keeping in mind the gravitational interactions of the bodies present there. But we were only able to discover all of Pluto's moons between 2005 and 2012. Overall, if we look at it, in 1986, we did have the option to fly by Pluto, but apart from Pluto's address, we didn't know anything else. It would have been like driving with your eyes closed in an unknown place where you have no idea what could happen at any moment. And probably no one would want to take such a risk. Voyager 1 had onboard some cameras, a spectrometer, a plasma experiment, and sensitive magnetometers. Apart from this, it also had a radio, an active battery, and some default instruments which could obviously explore Pluto. In 1980, when the decision to go to Pluto had to be made, at that time the distance to Neptune and Pluto was also almost the same. Now, since Voyager 1's instruments are still working today, so this means that they would have easily worked all the way to Pluto and we would have successfully completed the journey to Pluto. But there's something else interesting here as well. It's true that Voyager 1 was capable of mapping Pluto and its moon Charon. It could study Pluto's atmosphere and its basic properties, but the Voyager team didn't design this mission to study small moons, which were later discovered near Pluto, and Voyager wouldn't have been able to explore Pluto in as much detail as we could with New Horizons. And that's because Voyager used sensors from the 1970s, and after that there was a big revolution in the world of computer processors and sensors. And after that, at the beginning of the 21st century, when we worked on the sensors to be used in New Horizons, we could clearly see the gap in technological advancement here. You can get an idea of this from the fact that Voyager 1's ultraviolet spectrometer had only 2 pixels, but the Alice ultraviolet spectrometer on New Horizons had more than 32,000 pixels, which means New Horizons could study Pluto 16,000 times more efficiently than Voyager. New Horizons had much better mapping cameras than Voyager, and also a radio science experiment that was meant to study Pluto's atmospheric pressure and temperature. In addition, a dust impact detector was also installed on New Horizons, but Voyager didn't have any such technology, although Voyager did have a large antenna and a large backup battery. Because of this, it could transmit signals about 10 times faster than New Horizons. However, its memory was far smaller than New Horizons. Because of this, the data set we received from Voyager was very limited. So from this, we understand that if Voyager 1 had visited Pluto, we would have received data. But the quality of that data wouldn't have been as good as what we got from New Horizons. If Voyager 1 had really been sent towards Pluto in 1986, then for sure all those discoveries would have been credited to Voyager 1 today, the ones we made in 2015, but we would have had to compromise here. With data and diversity, New Horizons provided us with many different kinds of data, whereas in the case of Voyager 1, this data would have been limited. In 1986, we didn't even know about the Kuiper Belt, and we might have missed it. We wouldn't have studied any other Kuiper Belt object except Pluto. We would have just kept moving forward in that dark space. But that didn't happen with New Horizons. In the New Horizons mission, we studied several primordial Kuiper Belt objects even after Pluto. Just imagine how it would feel if, just a week before reaching Pluto, we found out that Pluto actually has its own atmosphere. Besides that, its small moons orbit it. There's much more nitrogen on its surface than we estimated, and methane is also dominating its atmosphere. Just 1 week. It would have been really amazing to find this out earlier, but the Voyager team would definitely have thought if only we had known all this before. But make no mistake, both spacecrafts here are extraordinary. Both have their own place in history, and both are the best in their own way. The teams, engineers, and scientists working on both projects deserve appreciation. Their decisions and leadership have given all of humanity a chance to step beyond this solar system. They are the real stars of this story, and yes, whenever the story of venturing beyond the solar system is told in the future, they will surely be remembered. And Pluto, even though it is millions of years old, no matter where it came from, we have only just begun to learn about it. This is the planet that is even named after the god of darkness, Pluto. In other words, this planet orbits the Sun as a dwarf planet. So then, how did an icy and rocky planet suddenly appear after Neptune? Apart from this, on Pluto, it remained so mysterious. It became important for NASA to learn about Pluto because Pluto played a key role in the process of the formation of our solar system. It was a link between our solar system and the dark, mysterious world beyond it. By learning about it, we could uncover many mysteries of the solar system. And that's why NASA planned the New Horizons mission to Pluto, which did a flyby near Pluto on July 14, 2015. And the data we received from this mission was not easy for everyone to digest. It was surprising how such a small planet so far from the Sun could hide so many secrets within itself. Clyde Tombaugh was the person who discovered Pluto on February 18, 1930, and with this discovery, a series of mysteries also began. For the next 58 years or so, Pluto, its atmosphere, and the activities happening there remained a mystery for us humans. But then, something special happened in 1988. By using the stellar occultation process, scientists discovered the atmosphere on this planet. Who knows how long this moment had been awaited? Stellar occultation is a phenomenon. When any planet or body passes in front of a bright star, the gradual dimming of that star's light reveals information about the atmosphere, the planet's size, rings, and much more. People had been speculating about this for decades. If Pluto didn't have an atmosphere, the light coming from the star would have been suddenly blocked as Pluto passed in front of it. But when this occultation happened, the starlight gradually dimmed, and because of the starlight, Pluto's atmosphere was almost glowing. The data received from space and the study of Pluto, they discovered the layers of its atmosphere and also identified the elements present in it, such as nitrogen, methane, carbon monoxide, and other gases. The elements that cover the surface of this planet. When astronomers graphed the light data, another conclusion emerged. The light did not penetrate Pluto's atmosphere all the way to the surface. This indicated the presence of clouds, fog, and similar phenomena there which were blocking the light. Apart from this, astronomers noticed certain symmetries in the light curve which confirmed that this dimming was indeed due to the atmosphere. And this is how we found out that Pluto also has a blanket of gases around it which we call the atmosphere. Now, the existence of an atmosphere on Pluto was completely confirmed. Now, we wanted to know about the temperature changes that happen in its atmosphere during its 248-year orbital period. Let me tell you, Pluto completes one revolution around the Sun in about 248 Earth years. Its orbit is highly elliptical, so much so that when it is at perihelion, that is, at its closest distance to the Sun, it remains at a distance of 30 astronomical units from the Sun. Let me tell you, 1 astronomical unit is considered to be the distance between our Earth and the Sun, and when Pluto is farthest from the Sun, its distance becomes about 50 astronomical units, which means almost 50 times the distance between the Sun and our Earth. But this difference of 20 astronomical units between the closest and farthest points in its orbit gives rise to interesting chemistry in Pluto's atmosphere and on its surface. We know that Pluto is a rocky body, but it is covered with ice on the surface. When it comes close to the Sun, the temperature of its surface rises to minus 220 degrees Celsius, and because of this, the frozen ice on its surface sublimates and enters its atmosphere. Sublimation is a process in which any substance in solid form changes directly into gas without turning into liquid form. So, the frozen nitrogen ice on Pluto turns directly into molecular nitrogen when the temperature rises. Earlier, astronomers believed that as Pluto moves away from the Sun, its atmosphere must freeze, and after going below minus 240 degrees Celsius, all the gases would freeze. In this way, one day Pluto's atmosphere would collapse. But observations forced scientists to reconsider because the results of the observations suggested that it was possible. Instead of Pluto's atmosphere collapsing, it is actually getting thicker as it moves around the sun. Researchers studying its elliptical orbit claimed that Pluto's carbon monoxide has increased the density of this planet over the past few decades. The molecules, which are carbon monoxide, have spread up to more than 300 kilometers above, and the solar winds carry them away from this planet, so carbon monoxide is continuously disappearing from Pluto's atmosphere. It is getting lost somewhere in the dark space along with the stellar winds. So then, how can carbon monoxide increase on Pluto? The answer to this is a bit complicated, but you will definitely get it later in the video. But for now, no one has any doubt that this planet, which is so far from the sun, is completely cold and frozen. But this is where the story of Pluto's atmospheric composition gets interesting. Thanks to methane, Pluto experiences global warming. Yes, Pluto has global warming. Methane is a greenhouse gas. It absorbs the infrared radiation coming from the sun, and in this way, Pluto's temperature keeps increasing continuously. Because of methane, there is a temperature gradient on Pluto in which the temperature increases up to minus 173 degrees Celsius with altitude. In the same way, a pressure gradient is also at work here. On its surface, the pressure remains up to 20 microbars, and with height, it goes down to 3 microbars, and after that, it keeps decreasing continuously all the way to the vacuum of space. From here, due to the interaction of hot and cold air and the variation of higher and lower pressure, winds blow on Pluto. But the formation of winds is not due to the vertical temperature and pressure gradient, but rather due to the horizontal temperature and pressure gradient. Now, on Pluto, there are also changes in temperature and pressure in the horizontal direction. For example, due to the sun's uneven heating or because mountains block the sun's heat, there is a difference in temperature. Apart from this, due to the uneven distribution of nitrogen on the surface, there are also changes in pressure. And because of these horizontal gradient changes, very strong winds blow on Pluto, and due to these winds, the ice gets redistributed all over Pluto. In a study, scientist Angela from the SETI Institute found that winds on Pluto blow at a speed of at least 37 kilometers per hour. However, several climate models have also suggested that the maximum wind speed on Pluto can reach up to 360 kilometers per hour. These winds blow 100 kilometers above Pluto's surface, and at this height, there is no friction caused by the surface. There is nothing to slow down the speed of these winds, which is why it is believed that such high wind speeds are possible on Pluto. This is just like our Earth, where the speed of the winds increases with altitude. But scientists are surprised that on Pluto, this speed makes things much more interesting than expected at an average distance of 6 billion kilometers. Even so, solar winds reach Pluto's atmosphere, although by the time they get to Pluto, they become 1,000 times less dense than they are on Earth. These solar winds contain protons, electrons, ionized helium, hydrogen, and oxygen, which reach Pluto at a speed of 300 to 500 kilometers per second. Both solar winds and UV radiation play a major role in Pluto's atmosphere. Scientists believe that due to ionized UV photons, Pluto's atmospheric gases also become ionized, and then they are picked up and carried away by the sun's interplanetary magnetic field. Solar winds themselves slow down. The laws of physics say that momentum, that is, the product of moving mass and velocity, is always conserved. In a system, it can neither be created nor destroyed, but in colliding bodies, it can be transferred. Just like when solar winds enter Pluto's atmosphere, their ionized molecules ionize some gas particles from Pluto's atmosphere and carry them along. Here, it's clear that extra mass is being added to the system, so to conserve momentum, the speed or velocity decreases accordingly. This mysterious process keeps happening continuously in its atmosphere. As we mentioned earlier, there are also a lot of clouds and fog present in its atmosphere. Molecular nitrogen, carbon monoxide, and methane are the main ingredients of its atmosphere. On Earth, we call this part the troposphere, where the temperature decreases as we go higher, causing the water molecules in the atmosphere to become supersaturated and form clouds. After this, in the stratosphere, the temperature starts increasing again with altitude. On Pluto, the troposphere is not very thick. In fact, it is only 1 or 2 kilometers thick. That means on Pluto, clouds form very close to the surface. Now, when clouds are forming, there should also be precipitation, and on Pluto, it snows. But this is not at all like the normal snow that falls on Earth. It's not just different in composition, but it's also different because of Pluto's atmosphere. Earth has a very dense and thick atmosphere that's filled with a lot of water molecules, but Pluto's atmosphere contains far fewer water molecules. The particles are very fine, their size is in microns, so definitely because of this. Snowflakes like those on Earth don't form here, but still, the snow here does follow regular hexagonal symmetry. These are like the babies of Earth's snowflakes, baby snowflakes. Just watching snow fall from the sky isn't enough for a space lover. There's a different kind of joy in watching auroras in the night sky. Astronomers believe that Pluto has a small ionosphere and also a weak magnetic field, which means auroras can also be seen on Pluto. But still, because the atmosphere is thin, the chances become quite low. Pluto's magnetic field is still a mystery for us, and without a magnetic field, we can't even imagine auroras. So, the concept of auroras on Pluto also depends on whether certain other things exist or not. However, the mystery you are about to hear has changed all our previous assumptions about Pluto. We have already talked about how Pluto's atmosphere is leaking, but a surprising discovery shocked astronomers, and that discovery is cryovolcanism, the volcanic eruption of materials like water, ammonia, and methane. Astronomers were amazed that even after the leakage, the amount of gases in Pluto's atmosphere kept increasing. Even in the last few decades, Pluto's atmosphere has become thicker, and that's also because of these cryovolcanoes. A study conducted by astronomers found that for cryovolcanoes, there should be carbon monoxide, molecular nitrogen, methane, and molecular hydrogen in the atmosphere. If any of these things are present in excess on any body, then understand that the chances of cryovolcanoes on that body increase significantly. Along with this, there is also a possibility of cryovolcanoes on Pluto's largest moon, Charon. However, we do have data that tells us so much about Pluto's atmosphere. The gases released from cryovolcanoes enter its atmosphere, and that's why the amount of gases in Pluto's atmosphere keeps increasing continuously. And that's the reason why Pluto's atmosphere is getting thicker. These volcanoes tell us that there are still activities happening inside Pluto, which means Pluto is still alive. We have been able to understand its atmosphere, its geographic features, its moon system, and some of the activities happening on it much better. But even today, many mysteries are still buried on this small planet with a diameter of just 12,500 kilometers. We definitely need to think about these, but even after knowing so much, there are still things related to Pluto. There are some misconceptions that people have which are not correct at all. There are some questions for which people think they have the answers. But with changing times, either those answers have become outdated or they are completely wrong. For example, was Pluto named after a Disney character? Was Pluto ever a moon of Neptune? Or is Pluto an icy world? There are many such questions that revolve around Pluto. Myth number 1. The name Pluto originally belonged to a Disney character. If you look at the chronology of these Disney characters, this myth will end right there. Pluto was discovered in 1930, and although the famous Disney dog also debuted in 1930, but in the beginning, this dog was originally named Rover. There was also a character named Pluto the pup, but even that wasn't broadcast until 1931. Most people were saying that the girl who named this planet Pluto had taken the name from Pluto the dog. But now it's proven that the dog's name Pluto was inspired by the planet Pluto. Let me tell you that Venetia Fair, when she was a schoolgirl in 1930, gave this planet the name Pluto. In a 2006 interview with the BBC, she also revealed this. Myth number 2. Pluto is tiny. Even today, many people think that since Pluto is a dwarf planet, it must be very small, about the size of an asteroid. But let me tell you, Pluto has a large diameter of 2,360 kilometers. That's about 2/3 the size of our moon. And it can also be compared to Jupiter's ocean world moon, Europa. Not only that, Pluto's largest moon, Charon, is about half its size. Charon's diameter is 1,207 kilometers, while Pluto's diameter is 2,360 kilometers, and that's why the pair is sometimes considered a binary system. Scientists believe that Pluto is the largest object in the Kuiper belt, meaning that after Neptune's orbit, Pluto is the largest object. Comets make up the majority in the Kuiper belt, and they are only a few kilometers in size, although some comets can be hundreds of kilometers large. But Pluto is even bigger than the other dwarf planets like Eris. Pluto's orbit is on average 4.8 billion kilometers away from the Sun, and this distance is really very large. When seen from Pluto, our Sun looks just like an ordinary star, but a bit brighter, and that's why. Some people believe that Pluto's surface is always in complete darkness for 24 hours, but that's not the case. During the day, it's not as dark on Pluto as people think. It's something like what happens on Earth when there are dark clouds, or the kind of darkness we experience here on Earth when the sun is about to set. But that's just how dark it gets on Pluto too, which means if a person goes there, they will definitely be able to see everything, but in some cases we might need lighting there. This is an old theory that became popular right after Pluto was discovered, and in 1965 this theory was disproved. People used to think that Pluto is not a Kuiper belt object because Pluto is perfectly round, while Kuiper belt objects are not that round. Its structure looks like that of a planet from our inner solar system. And this was the reason why people were under the misconception that Pluto is a moon of Neptune, and for some reason it got separated from Neptune. But later, when these two bodies were studied using the concept of orbital resonance, it was found that these two bodies were never that close to each other, which completely eliminates the possibility that Pluto was ever a moon of the planet Neptune. High-resolution images of Pluto were taken by modern telescopes and the New Horizons spacecraft, in which it was clearly visible that Pluto is completely covered in ice. And this ice is not just made of water, it is made of frozen nitrogen, frozen methane, and so on. If we look at Pluto's density, we find that its density is almost double that of water ice. The conclusion drawn from this is that 2/3 of it is made of rocks and 1/3 is made of ice. Therefore, it would be more accurate to say that Pluto is a rocky body with only its surface covered by ice. Myth number 6. Pluto is airless. In 1980, scientists discovered an atmosphere on Pluto, and it was found that Pluto's atmosphere is mostly made up of nitrogen, just like on our Earth. But along with this, Pluto's atmosphere also contains a large amount of carbon monoxide and methane, which escape into space. However, even then, compared to Earth, the atmosphere is very thin. For example, Earth's atmosphere extends up to about 600 kilometers, which is about 10% of Earth's radius. On the other hand, if we talk about Pluto, its atmosphere extends up to 7 Pluto radii. That means the volume of Pluto's atmosphere is about 350 times greater than Pluto's own volume. And that's why it can't be said at all that there's no air on Pluto. There definitely is air on Pluto. But whenever Pluto goes very far from the Sun in its orbit, all the gases in its atmosphere freeze because of the cold, and then there's very little air there. But when Pluto comes closer to the Sun, the ice melts and the amount of air and gases in the atmosphere increases. So this is how Pluto's atmosphere works. Pluto's orbit around the Sun is not perfectly circular, but rather elliptical. It comes as close as 4.43 billion kilometers to the Sun, and at its farthest point, it is 7.36 billion kilometers away from the Sun. Along with this, Pluto's orbit is tilted at an angle of 17 degrees to the ecliptic plane of our solar system, and compared to the orbits of the other planets, Pluto's orbit is quite different. Along with this, Pluto's orbit crosses Neptune's orbit. Because of this, for about 20 years, it remains closer to the Sun than Neptune because of this. In 2006, the International Astronomical Union unanimously removed Pluto from the official list of planets and included it in the category of dwarf planets. But if we look at Kuiper Belt objects, then other dwarf planets like Eris and Haumea have orbits that are even more elliptical and inclined than Pluto's. So friends, these are the kinds of There are also mysteries like these that surprise us, friends. At one time, Pluto was considered a planet, but today it is called a dwarf planet. Similarly, in the 1990s, reaching Pluto was quite difficult for our scientists because Pluto was very far from the Sun. And it is also surrounded by many celestial bodies. Maybe that's why reaching here was nothing less than a challenge for us. But with time, research on Pluto kept increasing. And at one time, it was considered one of the 9 planets that revolve around the Sun. But a few years ago, it was removed from the category of planets. Until 2006, Pluto was also considered a planet, but after that, Pluto lost that status because it could not fulfill some of the conditions set by the International Astronomical Union for being a planet. And in this way, it was removed from the list of planets and placed in the list of dwarf planets. Let me tell you that the planet Pluto was first discovered on February 18, 1930 by astronomer Clyde W. Tombaugh at the Lowell Observatory in Arizona, USA. American astronomer Tombaugh discovered this planet when he noticed a deflection in the calculations of the motions of Uranus and Neptune due to a large object, and that's when he saw this planet. Pluto was named by a student from Oxford School of London, and she said that in Rome, the god of darkness is called Pluto, and since this planet also often remains in darkness, it should also be named Pluto. Also, the atmosphere of this planet is made up of nitrogen, methane, and carbon dioxide. Let me tell you that Pluto completes one orbit around the Sun in 248 years, and it has a total of 5 satellites, out of which the largest satellite is Charon. In 2011 and 2012, Styx and Kerberos were discovered. Meanwhile, Pluto, due to its What was the main reason for removing it from the list of planets? The International Astronomical Union stated that Pluto was unable to meet all the criteria of the definition of a planet. According to the IAU, a planet is considered a celestial object that revolves around the Sun just like the other 8 planets do. Also, that object should have enough gravitational mass so that it can achieve hydrostatic equilibrium, meaning it can take a spherical shape, and it should have enough force to clear its orbit around the Sun and revolve independently, but its orbit intersects with Neptune's orbit. And in this way, Pluto does not meet the criteria to be considered a planet, so it cannot be regarded as a full-fledged planet. And by the majority of the International Astronomical Union, a consensus was reached that Pluto is a not a planet, that this ice is red in color, and there is a big reason behind it as well. But when research was done by NASA, several volcanoes were found here at once, and these are nothing like the volcanoes present on Earth. Instead, these are icy volcanoes which are called cryogenic volcanoes. They don't erupt lava like regular volcanoes, but instead they erupt ice. NASA has reported that about 10 such volcanoes have been found here, whose height can range from about 1 kilometer to 7 kilometers. It was also reported that such volcanoes have so far only been seen on Pluto. Such volcanoes are not present on any other planet, and the volcanoes present on other planets contain nitrogen, methane, and carbon dioxide. Although Pluto's sky is completely blue due to its chemical composition, the ice that forms here also appears red, which is a result of the various changing compositions occurring here. When Pluto orbits the Sun, at one point it gets very far from the Sun, which causes the temperature to drop, and icy mountains actually form here, resulting in increased cold and the formation of methane frost. These mountains are absolutely unique in the solar system, and this phenomenon is only seen here when the temperature drops. Pluto is located about 3.6 billion miles away from the Sun, and if we estimate, this distance was covered by a spacecraft that passed very close to Pluto, which gave us a lot of information about Pluto's orbit, and also this. Because of this, the cold starts increasing here. Research has found that there is a lot of turbulence on Pluto, which is why the cold increases here. Associate Professor Takashi Ito's research shows Pluto's orbit is fundamentally different from planets that move around the Sun in circular orbits. Its orbit comes close to a certain line, and as it moves outward, the area gets colder, which is why its orbit has this effect. This is what we call an eccentric orbit. Because of its movement like this, Pluto spends about 20 years in each of its orbits when it can be seen moving inside Neptune's orbit. By the way, Pluto moves in such cold that it rotates like Venus, and because of this, the Sun appears to rise from the west there. Because of this, the cold increases here, and that's why it feels so cold here. Just like our Earth has 365 days in a year, but on Pluto, 1 year is equal to 248 of our years. There is another special thing related to Pluto that makes it different from other planets. Let me tell you that there is a heart-shaped formation on the surface of Pluto, which is also called Pluto's heart. There are many secrets hidden on Pluto that scientists are constantly trying to discover. So friends, how did you like today's information? Be sure to tell us in the comment section below. If you liked the video, please like it and share it with your friends.